that x implies y. X implies y. So truth implies truth. Implication is true. Truth implies false. This can't be the case. Implication is false. False, whenever we have in implication hypothesis is false, so this is the implication is vacuously true. So these two are vacuous truths. For this implication, note carefully that this is the hypothesis column and this is the conclusion column. So in hypothesis column, if we have false, okay, let's go one by one. Hypothesis is false, so implication is vacuously true. Hypothesis is true, implication is false. Conclusion is false, so implication is false. Hypothesis is false, again vacuous truth. Hypothesis is true, conclusion is true, so this is true. Now you look at these two columns. They are exactly the same. So that's why these two are logically equivalent. They are either true together or false together. So we have this double implication is always true. So this is a tautology. And this proves the law of contrapositive. Okay. That's it. So we have now proved the basic laws of mathematical logic, and we are going to refer to them, back to them when we need them, and we are going to need them when we study step theory in the coming video. Coming video means this video has this probably will have some other parts. So after that, when we start set theory, we will need these laws. Right. Now, you remember I told you while discussing mathematical statements, some statements involved only constants. For example, 1 plus 1 is equal to 2. But there are some statements which involve variables. Right? So now the next thing is variables, and along with them there will be something else called quantifiers. Variables and quantifiers. Okay. Look at this statement. X plus 1 is equal to 2, where x is a real number. Okay. Now in this statement, x is of course a variable, but note that we have said that x is a real number. Now, as I have already told you that a statement is a sentence that is either true or false. For a statement not involving variable, it has a definite truth value. For example, this is true. This one is false. However, when we encounter a statement where we have variables, one or more variables may also be there, then its truth value depends on the variable. It does not have a definite truth value, but still it's a statement. Okay, still it's a well-defined statement, although it does not have a definite truth value. Actually, a statement involving a variable is a collection of other statements. This one has these statements: 1.1 plus 1 is equal to 2, pi plus 1 is equal to 2, and all the possibilities. So among all the possibilities, of course, once you fix the value of the variable, it becomes a statement with constants, and then it has a truth or false. It has a truth value. So while dealing with statements with variables, the truth value depends on the value of the variable. Now you can see one more thing. I want to draw your attention to this. Although x is a variable, we are not saying that x is 1 here. It's not about solving this equation. Okay, we are not treating this as an equation. We are treating this whole thing as a statement. So although we don't know what x is, but we know what type of variable x is. X is a real number. If you don't say this type, your statement may become meaningless. If you just simply say a variable, it can be anything. It can even be a non-mathematical object, for example, a chair, a table, or something like that. But since you cannot add a number to a chair, we have no operation defined like that, that will become meaningless. So when you use a variable in some statement, you have to state its type. Okay, what type of variable it is, that has to be stated. So the general thing looks like